Hello. So yesterday in class, or last time I saw you, we went through and we did a bunch of different activities, different events, experiments, and we looked at the probability, that experimental probability of things happening. So today what I want to do is show you some more mathematical examples and actually show you mathematically how we do those. So I'm going to start by defining a few terms. The first term is mutually exclusive events. These are events that cannot occur at the same time. So for example, if you flip a coin and you get a heads and a tails, that's impossible. You cannot get both of them at the same time. If you flip a coin, you either get a heads or you get a tails. Another example would be drawing a king or an ace. You cannot get both of those at the same time. So you're going to get one or the other. So those are mutually exclusive because they cannot happen at the same time. Independent events are events where the probability of one event does not affect the probability of the other event occurring. So for example, if I flip a coin and I roll a dice, well, if I get a tails on my coin, that does not affect me getting a 6 on my dice. I can roll the dice, I can flip the coin. It's not going to change the outcome one or the other. Dependent events then are events where the outcome of the first event influences the outcome of the second event. So for example, if I draw a card from a deck, a standard 52 card deck, and keep it out, then that impacts the probability of me drawing another card. Because when I do that, there's a 1 out of 52 chance of getting a specific card out of a deck. If I pull out a card and I keep that card out, there's now only 51 cards left in the deck. So I have a 1 out of 51 chance now of getting a different card. So it does impact what happens to the next card based off of what I draw first. So if you look at some examples, it says you roll a number cube. That would just be like a standard dice of 6 sides. Let E represent the event, roll an even number, and let T represent the event, roll a 3 or a 5. If I want to find the probability of getting an even number or a 3 or a 5, that is the same as saying I'm taking the probability of event E plus the probability of event T. So anytime you see this or, you're doing some addition. While the probability of getting an even number, there are 3 total even numbers out of 6 possibilities. You could get 2, 4, and 6. Plus, I have 2 possibilities of getting a 3 or a 5. I can get a 3 or a 5. There's 2 of them. So 2 out of 6 chance of getting a 3 or 5. And that leaves me with a 5/6 probability of getting an even number or a 3 or a 5. Well, if you think about it, there's only one possible option left, and that would be getting a 1. So that's where that extra 1 out of 6 probability is coming from. Part B says, what is the probability that you roll an even number and a 3 or a 5? So in this case, I'm looking at the probability of an even number and the probability of a 3 or a 5. Well, if you think about this, if I want an even number, my possibilities are 2, 4, and 6, and none of these are 3 or 5. So it is impossible to get both an even number and a 3 or a 5 at the same time. So that has a 0 probability. For the final one, what is the probability that you do not roll an even number? Well, the event of me not rolling an even number would be me rolling a 1, 3, or 5. So the probability of not an even, there are 3 out of 6 chances, so that is 1/2. Here's another example. A box contains 100 balls. 30 of the balls are purple and 10 are orange. If you select one of the balls at random, what is the probability of each of the following events? So the first one, the ball is purple or orange. So if I'm looking at purple or orange, that's where I add again. So I have the probability of purple plus the probability of orange. That's the probability of getting either of those. Probability of purple, if there are 30 purple balls, there are 30 out of 100 ways that I can get a purple ball. Plus, if there are 10 orange balls, there are 10 out of 100 ways I can get an orange ball. Add those together, I get 40 out of 100. That's your probability. So sometimes people write probabilities as percentages. Typically, I'll write them as a reduced fraction, but you can do what you'd like. And that ends up being, if I reduce that, a 2 out of 5 chance, or 40%. For the second one, it says the ball is not purple and not orange. So now I'm looking at the probability of not purple and not orange. Well, if 2/5 is the probability of getting a purple or an orange, we know that all probability would be like 100%. Something's going to happen 100% of the time. That's what all your probabilities should add to. That's 1. I can subtract off the probability of getting a purple and an orange, and that's going to leave me with my leftovers. Kind of like in the last example when we looked at the probability of getting an even number or a 3 or a 5 was 5 out of 6. So if I wanted to reverse that and say what is the probability of not getting a 3 or a 5 or an even number, you would take 1 minus 5/6 to get 1/6, because that would be like getting a 1. It's your remainder. So same thing here. What I'm going to do is I'm going to look, okay, I have that first 100%, and then I subtract off what I don't want, and that would give you 3 out of 5 or 60%. Example 3, a jar contains 12 green marbles and 8 violet marbles. A marble is chosen at random from the jar and replaced, meaning they put it back into the jar. Another marble is chosen at random from the jar. What is the probability of choosing a green marble and then a violet marble? So what we're looking at is we're looking at the probability of green, and then we want to get a violet. When we're looking at doing one thing after the other, that is where we multiply my two probabilities. So I get a probability of green times the probability of getting a violet. Well, there are 12 green marbles, and if I look, there are 8 violet marbles, so that means there are 20 total marbles. So the probability of getting a green marble would be 12 out of 20. And then I put that marble back. So I still have 20 marbles in my jar, and there is an 8 out of 20 chance that I'm going to get violet. Multiply those together, and I get 96 out of 400. And then you can simplify that down to 6 out of 25. And again, if you want to write it as a percent, you can. But otherwise, 6 out of 25 chance of getting a green and then a violet. If you look at the difference in the second example, it says a marble is chosen at random from the jar and not replaced, meaning you kept it out of the jar. Another marble is chosen at random. What is the probability of choosing a green marble and then a violet marble? So in this case, you're looking at the same idea here, where you're multiplying the two together. If I take out that first marble, there's still a 12 out of 20 chance it's going to be green. The big difference though now is that I only have 19 marbles left because I kept that first green marble out. And I still have 8 violet marbles total. So the big difference here is looking at with replacement versus without replacement. If you do not replace the marble, it changes that probability because now my total marbles in the bag is 19, excuse me. Multiply those out, I get 96 out of 380. So if I simplify that, I get 24 out of 95. Another example, there are 10 cards in a box, 5 black and 5 red. 2 cards are selected from the box, one at a time. A card is chosen at random and then replaced. Another card is chosen. What is the probability of choosing 2 black cards in a row? So we want to look the fact that we have it replaced here. So that would be the probability of getting a black card times the probability of getting another black card. Once again, we are multiplying them because we are drawing a card and then drawing another card. Because my black card is replaced, if I look at the first probability of getting a black card on your first draw, there are 5 black cards and 10 total. Multiplied by, well, because we could put the card back, there's still 5 black cards in there out of 10 total. So I end up with 25 out of 100, which simplifies to 1/4 or 25%. The difference in the second example now is that you are choosing a card and then not replacing it. So we still want to know the probability of choosing 2 black cards in a row. So we're still looking at the probability of getting a black card and the probability of getting another black card. The only difference is that now I have a 5 out of 10 chance of getting a black card on the first draw because there are 5 black cards and 10 total. But now, because 4 cards remaining that are black, and there's only 9 cards total remaining. So if I simplify that, I end up with 20 out of 90, which is about 2/9% chance. And then we're just going to look at a couple other just types of things that you can do besides drawing cards or besides taking marbles out of a jar. So Callista cannot decide which shirt to wear today, so she chooses one at random. The probability of rain today is 40%. What is the probability that Callista chooses a yellow shirt and it does not rain today? So we're looking at the probability of yellow. Because it is an AND case, we are multiplying that by the probability of it not raining. Well, there are a total of 2 yellow shirts, and there are 4 total shirts. And the probability of it not raining, well, they tell us here the probability of it raining is 40%, so then the probability of it not raining is 60%. So if I write that as a fraction, that would be 3 out of 5. If you want to just plug it in your calculator and use 0.6, that's fine as well. I end up with 6 out of 20, which simplifies to 3/10. So there's a 30% chance that Callista chooses a yellow shirt and that it does not rain today. What is the probability that Callista chooses a yellow shirt and it does not rain today, or that Callista chooses a green shirt and it rains today? So this one takes a little bit more analyzing. We are looking at the probability of Callista chooses a yellow shirt and it does not rain. Well, we calculated that above, that's 3/10. Or we're looking at what are the chances she chooses a green shirt and it rains today. So for this probability, the chances of her picking a green shirt are 1 out of 4. The chances of it raining is 40%, which is 2/5. So there's a 2 out of 20, or a 1/10 chance that she picks a green shirt and it rains. So now, because I'm looking at the probability that either of these things happen, either or, I take that first probability, which is 3/10, and I add it to 1/10. So there's a 4 out of 10, or a 2/5 chance that these things happen. We're just going to look at a couple more examples. So you spin a spinner 2 times. Assume that the probability of landing on blue on each spin is 1/3, and the probability of landing on orange on each spin is 2/3. What is the probability of getting the same color both times? Well, the probability of getting the same color, that would be the probability of getting blue then blue, or the probability of orange then orange. So if I look at that, the probability of getting blue and then blue, well, the probability of the spinner landing on blue is 1/3. So that would be 1/3 times 1/3, which is 1/9. The probability of getting orange and then orange, well, the probability of landing on orange is 2/3. So 2/3 times 2/3, that's 4/9. I'm looking at the probability of either of those things happening. So the probability of you getting the same one twice would be the probability of getting blue then blue, plus the probability of getting orange then orange. So that is 5 out of 9. Here is the final example that we are going to do. There are 15 males and 16 females in this class. The cards are shown below are mixed and placed down. A student in the class is chosen at random. The student chooses a card at random. What is the probability that the student is a boy and that he chooses an odd number? So I would take the probability that the student is a boy, multiply it by the fact that he chooses an odd number. Well, 15 out of 31 students are male. There are 1, 2, 3 out of 5 possibilities of the card being odd. Multiply those together, I get 45 out of 155, which simplifies down to 9/31. So next you're going to go through and you're going to do your candy math. So make sure that when you go through, answer the cards, remember, or you're adding probabilities together, and you are multiplying them together. We'll go over these next time I see you, but otherwise, keep working and feel free to email me if you have questions.